Let me put some code up on the screen. Yeah, so um, so don't think too hard about the specific content of this code. Basically, I spend all my time thinking in systems land, and so I've been trying to think. Is there a way to or basically on nights and weekends, I've been trying to like actually write Urbit apps, right? Because I spend most of my time in the kernel. Um, and so this is what I'm working on recently, and I was this afternoon I was like, I'm gonna go and spend a couple hours to see if we make some progress on it. And when I started to do that, I was reviewing what I did last week because there's only one. Like this is only like I've only spent one session on this, like just a couple hours. There's not a lot of code here. And I was like, well, okay. Obviously, the most like the strangest part of this code, I have to look at it very close to tell, is this and all these things that are implementing it. And so I was trying to think, is that a reasonable way to do things? What are the other options? And I ended up getting stuck on that way more than I expected I would. Because it's actually, in a lot of ways, a pretty deep question. So I got stuck on that for a while, and then got really tired because I had Chinese food, and so I took a nap while thinking about it, which I think was helpful. That kind of thing is helpful if you're literally thinking about it hard as you go to sleep, which is what I was somehow able to do. By the time I woke up, the sun was down, and there's a thunderstorm outside. Very cool to see because I'm kind of up a little on a hill. Very cool to just see, flashes of lightning lighting up the whole valley, which is very cool. And helped me, still lie there thinking about the problem. And I don't know. I feel like I haven't come to a resolution yet. Anyways, so that's the setting. I'll dive a little more into the specific question here, and then try to think about all the analogies it has to other areas of the system. So basic premise of this is something that looks like that has a little map, and as the player you move around the map. It doesn't actually really work, but excuse myself, but there's a little 2x2 map right now, and officially I'm in this square, and like there's text associated with it. You should be able to move around with the numpad keys and so on. Nothing very complicated, but the idea is to be able to have different items in each square, and those items would have various properties and various ways you can interact with them. Generally, just kind of looking at like a sandbox type environment, where those items might be as simple as, you'd be able to do all kinds of stuff. Well, okay, so it could be, for example, a resource you need to mine, and then you have, like kind of Minecraft style. You have like a furnace. You got to put fuel in and an ore, and then you get the other, and then you get the iron ingots, whatever they call them, out, and you should be able to just kind of build all kinds of stuff in this. And a lot of the hard part of that, of course, is going to be coming up with specific ideas of like what those items would be, and there's a whole creative side to it that will be the hard part in a lot of ways. However, in the meantime, but like to even get to that point, there's a little bit of a systems problem, which supposedly I'm trying to avoid, but of course, oh well. Um, which is, how do you define these items um, in some way that they can all be treated the same by the system, but obviously have their own characteristics. And so there's a couple of ways that you can encode this kind of relationship, this kind of genericity, as it were. And the one I chose here is not the one that we most commonly do. I actually want to go ahead and write it up in a more usual hoon-like way to give a clearer sense of what that would look like. But first, I'll talk through this one first. So the idea, and I'll just keep adding items to it, but is a part, which is what I'm calling an item, can have a few different things. It can have a name. It can have a character that gets displayed on the screen. It can have what I'm calling size, which is, I'm not entirely sure what that means yet, but the first reason that I use it is to give us to show, like, if you have several items on the same place, which one should show on top. So which one should be displayed on the screen. This is all very just kind of, if I feel like I need something, add it, and I'll try to whittle it down to a cleaner core at some point. The text description of it, there's something can update its state according to how long has passed since the last tick. So the idea is to try to define the evolution of this in terms of real time, because real time of the server is kind of the most basic thing you can that you can kind of keep constant. There's a whole discussion to be had about, like, if you have people playing on your server on their own client, what kinds of things do you let them do versus what you need to enforce, because obviously the client could do anything. So there's it's sort of a security kind of question. And I think that I suspect that one of the foundations of that is to not rely on things like, basically, I mean, obviously, not rely on the client doing anything in particular, and instead rely on things that the server can control. So, for example, frequency of actions on the client is not something that the server can control. However, how long the player is in a certain mode or an item is in a certain state is something that the server can control. And so, and like, that's where it can sort of generate scarcity, is just out from time. So the idea is, every time you need to update this, you tell it how long has it been, and it can produce a new copy of itself, which this is a pattern that you'll see in some other places, where the important thing is that it might have some state, and that state might be updated. There's also the concept of push and pull, which is adding an item to this item, and removing one. If you're the player that's picking up an item and dropping it, if you're like, a furnace or something, it's putting fuel in or removing an item from it. Obviously, there'll need to be a bunch more, and I haven't tried to think of this as, I haven't tried to design the actual content of these. This is I'm doing it very kind of incrementally, try to get stuff working at every step. Anyways, so you have these ideas. Some of them are functions. Some of them are basically values, although notably these are arms, and so they can be they're computed each time. So they may be constant, but they don't have to be. Also, just to real briefly cover the other types here, the map is a map of spot to site. So spot is X and Y. this is, I think, in general, going to be a much better solution than like trying to do a 2D list or something like that. Spot to site. A site is a list of sites with a C. It's not a great name, but whatever. Those are unique IDs, which go into this sort of object map of unique IDs to parts. List of site, because you could have several items on a site. I think that we want that to be ordered, but maybe not. It's possible that should be a set instead. Anyways. Right, so back to parts. An example of one would be the player. The player has some state. They have what their ship name is, because you should be able to have players from multiple ships. And they have an inventory. Whole is just a part with its ID. So then you define the interface, right? The player, so name here is like it's an ID meant for the computer, not to be displayed. So this is a player. That's the size. That's the character. The text here is computed based on its state. Notably, this state is constant. We don't have a distinction though between constant and non-constant state. Nothing happens over time. You could imagine having like a hunger bar or whatever that decreases over time. You pick up an item. If it's too big, you can't pick it up. Otherwise, you do pick it up. You print out or just return some text about that, and you add it to your inventory. All right, return a new copy of ourselves with that added to our inventory. You drop an item. You go through, search for the item that you're dropping by ID, remove it. Again, if this, instead of a list of whole, was like a map of site to part, that would, that might make some of that nicer. I don't know if you really want ordering or not. I don't know. I could see a lot of options. Anyways, right, you drop it if you have it. Otherwise, you don't have that item. The other two items here are wood. There's no state to wood. There's just all of these items. Don't accept items, and so on. There's also the concept here of a campfire, which has how much fuel it has a name, a size, a character. Its text depends on its state, right? If it has fuel, then it is burning, and if it doesn't, then it is dying. As time passes, we burn this fuel down to empty. If you're putting something in it, then if it's not wood, then you can't put it in the campfire, at least at the moment. If it is wood, then it goes in there. Great. That gets added to our fuel. If you try to remove something from it, you could imagine saying that you're able to remove some of the fuel from it, and then you'd have wood again or something like that. But a campfire, we're going to say everything is burning, and it's you can't do that. Notably, I didn't cast any of these to part here. I do this to sort of prove that they do cast to it, but I forget if it's required that I don't cast them here. The types on this are a challenge to get working. This does work, by the way. This obviously, we saw it working over here. This is all compiling code. I don't have a way. I haven't implemented a command to, for example, pick up items and put them in the campfire, or even move around the map yet. But at least this part compiles. Those are the types, and then we have some helper functions. For example, printing out the map, which looks basically like you'd expect. Find the max x, y, loop through, and get the items. If there's nothing there, put a dot. Otherwise, take the character. So this is how you. So if we look back up here, right, tough is the map of site to part. So right, we're going through the land, which is the map. We have a particular X and Y we look up. If we find anything there, then is that even correct? Yeah, it's correct. No, it's not correct. Or yeah, sorry, it is correct. We only do the top item in the site. Okay, so what was it saying? Right. So in the land, we get the list of site. Look that up. We get a part. So here's a part, and we want to say what's its character. Well, we invoke the character arm on that part, which is going to be a character, pat TD, capital D like that means block size 3, which is 1 byte. And so, yeah, that's how you print out the map. Examine, which is what the 5 key here does, says, okay, examine a particular spot, look it up in the land. There's either something there or there's not. If there is something there, then do the same kind of thing, except in this case, we're going to actually print everything that's there, one after the other. And yeah, we pull the text arm from the part. Next tick does a similar thing. The difference here is that when we call tick, and we call it with how much time has gone by, but we use run by. So the result of this actually gets put back in the tough. I don't remember if this doesn't get called anywhere, but that's how it would work, right? This produces a new tough. This whole thing, in case you missed it, is inside. You have land and tough available to all these functions. And so, yeah. The code here is a pretty standard just shoe file that the only command that's really implemented. Yeah, so it either just prints out the command for all the other ones, but if it does get the examine one, which is number 5, that's the only command that's implemented, then it runs examine at a particular place, literally just hard-coded 1-1. That'll, that's one of the things that'll change once you can actually move around the map. And it prints it out. It also prints out the whole map, right? That's this is. S is defined here, but I think it must get redefined. Maybe? Yeah, there. We fill in the land and tough. Yeah. Okay, so that's all pretty standard, pretty easy. There's nothing terribly complicated about the app, certainly. And this is readable code. This is not bad. But it is a fairly unusual style. We do not commonly use this. So I want to show what it looks like. And a lot of my point here is to think through this myself. So I want to show what this looks like in a context where, or basically, I want to rewrite this into a more traditional hoon style, and then think about what are the good and bad parts of each of these. So I'll make a new file called soul instead of soil. We'll see what this looks like. Okay, so these types will all stay the same, but part is going to look different. So what part would look like is we say it's going to be a buck send, right? It's going to be a tagged union where the tags are, it could be a player. And what is the state associated with the player? We don't have any of the functions here. We only have the state. So it's a ship and an inventory. Wood. Let me do this then here. So it could be wood. It has no state. Campfire. It has an amount of fuel denominated in time, in relative date, what DR is. And then we're going to have all these functions, but they're going to be actual functions. So instead of having this section, this part's not necessary anymore at all. We're going to implement each of these functions separately. See, works. Okay. Now we have code that works. It is almost exactly the same length. I think it might be overall maybe a little bit wider. I don't know. Actually, it's not really. But the structure is very different. Last thing to jump into now is we want to look at what what's the difference between these two styles? So in the kernel, this style, soul style here, is significantly more common. In a lot of ways, it's a more functional style. It's a style that's much more common in functional programming than this style. It groups things obviously in a totally different way, right? Here we have each attribute, each characteristic. It's sort of characteristic oriented here, whereas here it's oriented around the items. And so you say, okay, I can learn everything you need to know about wood or about a campfire in one place. Whereas here, it's like I can learn what all the different text answers are, what all the different behaviors are on tick. And there's something about this that feels kind of terser and cleaner. And part of that has to do with the fact that that the actual thing that you're dealing with, the item you're dealing with, is this tagged union. And tagged unions are just much simpler than whatever this type is, right? This is some kind of interface type that, like, if you tried to describe its type precisely in, say, in kind of like a normal lambda calculus, like type lambda, or I forget the name of that type system, but like, you can describe this, but it's not going to be clean. And this is just a sum type. It's just, yeah. And each of these functions is just a function from a sum type to a regular type. The theory doesn't matter that much, but it is, but it's a, but like, the subjective feeling of this is very concrete comes from the fact that it's just conceptually a lot simpler than this. It's a lot simpler. Like the left side here is a lot simpler. Is there a power difference, really? Not really. I'll call them soul and soil because that's what these are called. There's not a great reason for those names. Soul is just a perturbation of soil. Soil is just the name I'm using for this app. But yeah, this is conceptually simpler. It's sort of more concrete because you're operating on data and not code, generally. Not these sort of opaque cores. If you were to write an upgrade for these, to write an upgrade for one of these, you actually need to have a save or something that produces your state and then a load that takes in, old state version and produces, something like this. Right. Because the data is not directly available there. Whereas here, what you would do is just have another one of these that you don't need to stay at all because it's already like at every moment it is resolving down to the at every moment it's resolving down to the data structure. It doesn't stay as code. If you make these produce instead of part, make them produce the core, then you might have an abet, which is kind of like a stay arm, I guess. And then your load goes here as you get it's some kind of old part, and you do hep.old part and say, okay, if it was a player, then we do something like, obviously here the state's not actually changing, and so it looks like it's an OOP, but it would not be if the state actually changed. Right, so something like that. Which, I mean, this is just like everything else. This looks really nice because it means you keep all your upgrade code in one place instead of sprinkling it throughout everything, right? That's nice. It really is. Get just a little bit narrower. All right. If you want to add an item to this, then I don't know if this is a pro or a con. These are more like characteristics. To add an item over here, you just write a new block of code. Whereas to add an item over here, you need to change a bunch of different functions. So does that matter? Well, maybe, right? Like the Hoon compiler uses this style, where the tags are either usually either like Hoon runes or type stems, right? There's lots and lots of we take a quick look at that. We can look at mint, for example. This is the top level of the compiler. It's like, okay, what are all the different runes? How do we compile them? And this uses a lot of that king side, queen side mixed sort of notation. I would be tempted to do this kind of thing more, but it's fine. If you do this whole thing as just pure queen side, it's huge. And anyways, so that kind of thing is common here. And Mull goes through all the same runes, right? There's a couple more. Play goes through all the runes as well. There might be another one. I feel like there is. Maybe not. Mint, Mull, Play. And so if you want to go through and add another rune, you have to go change these various different functions. And the compiler obviously will tell you, because these are all whatheps. Well, they're not all whatheps. Some of them are like Mint, for example. I mean, technically it's probably a whathep, but it has a tar case where it goes to expand a synthetic rune. I think they all do that, actually. So the compiler won't help you. You'll just set the compiler into a infinite loop. But it isn't actually, like, practically it is not difficult to go find the 3 or 4 functions you need to update and update them if you're just adding a rune. And obviously, if you're adding a synthetic rune, it's really easy. You just do it in open because they all defer to that. They all defer to that to resolve down natural runes. But even for a natural rune, it's just not that hard. Types, those get used in a few places, right? Fork is, I think, only ever used as a type. Let's see. So there you have, gain has it. There's a bunch of these times where you're pattern matching on types. And if you add a type, you got to update all those. It's a little harder because there's a little more of them. But again, it's really, there's no synthetic ones, so the compiler will yell at you if you miss it somewhere. It's not that bad, but it is very different than just adding a single block. You could write the Hoon compiler that way, I believe, where each of these Hoons, instead of being a Buxen, right? This is written like this. Instead of being a Buxen, they could have, for example, for runes, it looks like it's basically mint, Mull, and Play. You would just have mint, Mull, and Play things, and that would give you an interface that just has 3 functions. And anytime you get to one of them, you would just run it, right? You probably have another one for expand. That way, it can include synthetic runes. When you call expand, it either recursively expands, or if it's a natural rune, then it would just produce itself. And so you'd say, okay, mint from expand of this rune, and there you are. It's a style that I'm quite confident would work fine. But I feel like it would be very wrong in the Hoon compiler, because you don't actually want to think of these runes as, what are all the things that this rune does? I mean, sometimes you do, but more often, and sort of more fundamentally, you want to look at, okay, what does it mean to compile a wet gate, right? And so it's look at Mull, see what it does for each of the runes, and then you'll understand it. But I think that gets at, you kind of infer from what I just said, where these different styles are more valuable. If you're it's something like, if the so like here, for example, if we if you're regularly adding parts, regularly adding items to this, and in particular that you might add or remove. Well, it's not even regularly adding. It's, are there cases where you might want to load in some of these items without changing the underlying code? So the big advantage of this style is that because this is its own entire block of code, it could, if you wanted, live in a separate file. And it could be loaded entirely dynamically. So in the context of this sort of sandbox game, this gives you the ability to mod it very effectively, right? You can say, okay, here's a directory. Every item in this directory is going to become an item in the game. And they're all expected to have this shape. And you can add or remove items from the game by just, adding or removing them from that directory. By comparison, trying to do that in this style really does not work, right? You have to say, apply this diff, or patch file, whatever you want to call it, and hope that works out cleanly. But if it does, then it's like, okay, now it's going to change items in a bunch of these functions in a way that would be very sort of syntactic. And you can imagine a smart diff function, a smart patch function, I guess, that knows, like, okay, paste in this code there. And it knows how to look what function it's in, so it doesn't have to do it by line numbers or whatever. That's buildable, right? But there's a sense in which this is a sort of macro-oriented approach. This is the kind of thing that actually would be quite straightforward to do in Lisp, right? There's it is not difficult in Lisp to build a macro that says, I forget what they call, like run level 1, like the at macro compile time. Well, at the runtime of the macro, which is before the runtime of the actual code. I think they call those run levels. Let me make sure. Yeah, maybe. Okay, I don't see it immediately. I'll call them run levels, but it's, where there's your code's running, there's your macros are running to produce the text of your code. You can also have more and more levels of those in Lisp. And so you can have, during the macros runtime, you can load in from a directory a bunch of plugins or whatever you want to call them. Right here, there'd be objects, or objects is a lightning rod. Just items, right? Parts. And then you could generate these functions based on what those are. But if you're doing that, then you're really writing in this style. You're just trying to do it at the syntactic level instead of at the sort of code and value level. And maybe there's some benefits to that in some cases. You could imagine that being somewhat faster or whatever, but I'd be skeptical of that without, like, you always have to get to what the actual bottom line speed is to know for sure. But doing it syntactically has a ton of disadvantages, right? There's all kinds of ways for that stuff to interfere with each other. And so that's, like, not really a solution. You could do this, but then have, like, a meta one at the end that lets you invoke from here, or that lets you extend it. So there's like your real ones and there's the extension ones. The extension ones have this shape. But again, you're really just trying to smuggle in this shape into this code, which is which it's possible that a hybrid solution is correct, right? There's like that's a solution to a lot of things, but it's notable that you end up really wanting something that has this shape if you're extending this regularly. In the Hoon compiler, we're not extending it regularly, and we're certainly not extending it in the way where, where some people might be running some runes and other people might be running other runes. Like you don't load those in as like a plugin system or something. And so what we need to do then is we need to look at more examples. We should summarize for this, though. If we'll say dynamically as a vague word to mean I'll just say it has a lot of advantages. It's fine. But there's another example of so we looked at the Hoon compiler. It's written in this Soul style. However, it's also Gall. Gall is not written in that style. Actually, I want lull on this side, so if we look at Gall's types, Gall's state is a few other things, but primarily map of term, which is app name, to yoke. Yoke is some metadata and the actual agent. If it's suspended, then it's just a base of its state. But if it's running, then it's an agent. What is an agent? An agent is this type. A bunch of these helper types. Form is the actual type. It is this. Does that look familiar? Also, arguably that should really be king side, but it's fine. This type doesn't look that different from this type. Okay, they all have this bool argument, right? That's just the that's more metadata about the app, like what you're subscribed to, what's the current, what's our ship name, current time, entropy, that kind of thing. We don't have this. At some point, you probably would have it. Not a significant difference. And then you have various functions. These are mostly functions. This is just an arm that doesn't take any arguments. But it looks very similar to this. This is a ket what because it has no argument. This is a ket bar because it's a door. So you want to be able to write to its sample. But like the rest of this looks the same, right? And the way this gets used is you have an app core that does various things, and it will sometimes invoke the agent. This is not the it's like p.agent. Wait, okay. Let me look at the yoke again. Yeah, so p.agent. Okay. p.agent. Right, so we'll often refer to this. And that just fills in that the argument to the door. So app agent core is the actual thing, and we just call functions from it. It looks just like the way we call functions here, just about. All right. We just call functions from it. These don't take arguments, but if they do take an argument, then it's that. we virtualize it, put it in a mule because it's user code. But this is a very different form of code than what the compiler uses, and it looks just like this. The way the Arvo loads vanes is also similar. It's a little less obvious because we don't have explicit types for it. It all happens at another vase level, which is another thing to talk about. But it does the same kind of thing. It has the same kind of pattern. And so why does Gall do this when the compiler does the other? And also, what would Gall look like if it didn't? Right? This is always a choice. Well, the items, what we call parts here is analogous to agents here, to apps here, right? And so you could imagine, what is it, app poke, right? App poke, when a poke comes in right now, we call on poke from the agent core. However, we don't have to. What we could have done is said, we don't write these agents all in separate blocks, but we actually have a big old whathap here. And we say, okay, which agent are you poking? Right? Hep dot. Well, it would just be like, yeah, okay, what agent are you? Or yeah, and there would be a type at the top that is a bucksen of agent name and the state of that agent. And you would have, for example, the Dojo app would be like, you're poking this. We'll say it's just with text, right? So we'll assert that it's a text poke, and then we will update our state. Produce a note, or sorry, it's actually just the whole agent with. Lines are text dot input following those, and then you're like, okay, what are the other things Dojo does? Well, you'd put them all in there. You can write the functions out separately elsewhere if you want, but yeah. What's the other thing you do? Well, maybe this is the pals agent and it's got its own things. Maybe this is whatever. All your agents would go there. It's sort of obvious looking at this why we don't do that. Because the unit of distribution for apps is an entire app. And you want to be able to run them or not run them without changing Gall. This is a choice. You don't have to do it this way. You could recompile Gall with each of these, and there'd be some really nice conceptual advantages. Right? Because like as much as this is, it feels wrong to be putting that code next to each other. This is so dumb, right? This is so just conceptually simple. Your agent type, instead of being this thing on the right, it's a bucksen. It's a bucksen of Dojo with lines, list pat t, and pals with set of pat p or whatever, and like that's really attractive to just be like, yeah, it's just data. Oh, you want to update that? Update it. But the thing is, it's not worth it because being able to distribute this stuff separately matters. It matters for agents. And when you do that, this style just breaks down. There's another level to this, which is that it's not just being able to distribute these, and so people might be running different ones of them. Like, there's a Conway's Law aspect of it, right? So Conway's Law says that basically organizations have this code that gets produced tends to have the same structure, the same topology as the organization that produced it. The official one specifically talks about the communication structures of the organization, but that tends to reflect. It's just really just saying, like, what's the actual organization or the actual structure of that organization, as distinct from maybe what it is on paper. And so, one of the ways that applies is, so just like very specifically here, in this style, you would tend to expect this style to get produced if your organization was set up to say, okay, here's a team that their job is to, manage evolution over time, right? So they're in charge of the tick function. And there's generally a particular set of items, and that everyone knows, and their job is to make them evolve over time. There's another team that their job is to, you're ingesting, and I don't think digesting is the opposite of ingesting, but divesting items. That would tend to produce code like this. And you can imagine using that for a Hoon compiler, right? You could be like, okay, here, here's a team, I don't know, that their job is to produce the knock that comes out of the compiler. And here's a separate team that their job is to do the type checking, right? Here's another job, and another team, and their job is to do some kind of partial evaluation, optimization, or whatever, right? And they would all be operating on the same set of runes. And if someone wanted to add a rune, they would need to communicate with the other ones, with the other teams, and be like, hey, we're adding this rune. Here's what I expect it to do. Here's how you need to handle it. And that, that works. As long as you're not adding too many of them, then that's fine. And that's probably a better structure for a compiler team than one that says, okay, you guys get these 10 runes and you guys get these 10 runes. And, if you need to add runes, you're welcome to add runes. But if you want to change anything about how the type system sort of really works, you need to get buy-in from everybody in a really broad consensus. And that structure seems unlikely to work very well. They're both possible, but so when you think of communication structures, it's basically within a team, you can do a lot of communication quickly, and between teams, communication is more expensive. So that's when you look at the Hoon compiler. If you look at something like Gall apps, if you like the kind of organization that would produce this code would be one where you have a team whose job it is to respond to pokes, and a team whose job it is to handle errors, and a team whose job it is to respond to subscription requests. And that's you can't even really think about it. So it's a team like that. Well, you can imagine it. You can imagine it if you had a really specific set of apps. But that's not how Gall gets used. It's not how it's meant to get used. What we have in practice is you'll have a team who's responsible for an app or for a set of apps, and might add or remove apps, and you don't want to have to coordinate or communicate with anybody else about you adding or removing an app. that should be only within your team are you talking about that. And if you want to, the place where you would need to communicate with other people is if you're going to change the interface for app poke or the interface for error handling, right? You're like, I need more information. Okay, everybody needs to know what those errors are. And so in that case, you definitely want. So in the case of Gall, yeah, you're adding and removing these things, even if there was no third-party software distribution under Urbit. Even if we were building everything and everyone's running exactly the same set of apps, you would still, just organizationally, it's going to be easier to think of it as, yeah, this team is working on this app, that team is working on that app. And because that's the way you want the communication structures to run, that's also the way you want the code to look. It's going to need to have this kind of a structure. And so if you start from there, right, I think that's it. I think that's the resolution of like, what are the differences between these styles? When would you use the one or the other? And so bringing that back to this particular app, the question is, how important is it to this app at this stage to be able to have items be added and removed dynamically in some sense, to think of it as the item is the thing and not the trait, not trait in any kind of technical way, just characteristic. And unfortunately, because this code, as I say, is conceptually simpler and is easier to write, frankly. The point of this app is that you can add and remove stuff, like that you think of items separately, and that you're going to be able to load them in from a directory or whatever, because at some point you want to say, any other developer on the network can mod this by just adding items. Is it possible that they're also going to want to add other characteristics? Yeah, and that's worth thinking about, and maybe that changes stuff. But I think it has to generally look like this, which is a little bit scary because we're frankly, not great at making this kind of code look nice and be terribly ergonomic. Our type system is sufficient for this. A technique that we commonly use, and that probably is worth using in this context as well, is to not try to do it as explicit types at this level, but do it, frankly, in a more like Lisp style, macro style, of loading in the core as a vase. So doing it one vase level down and poking at it. Not poking like as in poking apps, but as just like you check and see, does it have this function? Okay, then do this. Does it have that? Like, just do it in a very, very dynamic way. Which is a way that the old Gall used to do it. Arvo currently does it that way. We're talking about new Gall at some point, maybe doing it that way again. It gives you maximum flexibility. That's a whole nother sort of comparative analysis that's worth doing at some point. But the cost of it is you're doing all this vase code. Vase code's not that hard to read, but you're doing a lot of dynamic type stuff that you can put in the checks yourself, but compiler can't help you. It's just more complicated. It's a significant cost, but at some point you kind of need to pay it. And what makes Hoon a good language for something like Urbit is that it is able to do both of these styles actually pretty well okay. And if there's anything where it isn't able to do, you can always back out to a more complicated system that can do it. Yeah. Okay. I think that gives me the answer, basically. I should experiment with what are nice ways to do this instead of trying to bail back into this. I think I'm going to need to think of these as much more like agents and maybe just, yeah. Whatever experimentation I do there, we can always, if I find any cool tricks, we'll move it into the agent, that agent interface, which is probably going to be receiving an update, over the next, I don't know how many months for the subscription reform stuff. Okay. I think that gives me my answer. Yeah, I think I'm going to sign off. Cool. All right. I'll see you guys around.